In this video, we're going to take a look at the law of cosines. This is used to solve for a missing side length or missing angle measurement in a non-right triangle. It's best used when the triangle is given with SSS or SAS. Here's the law of cosines formula. Notice that the big letters represent angles and the small letters represent side lengths. Notice that in the formula, the only angle measurement is C. So if you have a triangle, you will always label your angle that you have or the angle you're trying to find as big C, and then you'll label the side lengths accordingly. In this first sample problem, I notice that I'm starting with SAS, two labeled sides and a labeled included angle. I'm going to start by writing down my formula. C squared equals A squared plus B squared minus 2 times A times B times the cosine of big C. I notice that the labeling on my diagram doesn't necessarily match up with the labeling of my formula, so I'm just going to change it on my diagram. My angle has to be labeled as big C, so across from that is little c. So I'm going to solve for little c in my formula. A and B are interchangeable, so I'll call this big A, so 16 is little a, and this big B, so little b is 52. So I'm going to plug things in. I'm looking for C squared. I know A is 16, so I have 16 squared. B is 52, so I have 52 squared. Minus 2 times 16 times 52 times the cosine of, and my angle measurement is 115 degrees. Since I have all of the things plugged in on the right-hand side of my formula, I'm just going to type that into my calculator. And when I do that, I get approximately 3,663.24. Last but not least, to get C all by itself, I'm going to take the square root, and I end up with 60.52 as my missing side length. In this problem, we're asked to solve for theta. I'm going to start by writing down my formula. C squared equals A squared plus B squared minus 2 times A times B times the cosine of big C. Remember that the only angle measurement in that formula is C, so I'm going to label theta as big C. So across from that is little c. Then I'll label over here as big A, making little a 32. I'll label the last one as big B, which makes 24 little b. If you flip-flop A and B, it will work out the same. So from here I'm going to plug in. So I have 37 squared equals 32 squared plus 24 squared minus 2 times 32 times 24 times the cosine of big C. We're going to take this one step at a time so we make sure that we do not combine terms that are not alike. So 37 squared is 1,369. 32 squared is 1,024. 24 squared is 576. All right, and since this next chunk is all connected by multiplication, I can take care of that all together. And 2 times 32 times 24, and I'm subtracting that, I have minus 1,536 times the cosine of C. From this point, I can combine my like terms, so I'm left with 1,600 minus 1,536 times the cosine of big C. I'm then going to subtract 1,600 on both sides, which leaves me with negative 231 equals negative 1,536 times the cosine of big C. Next, I'm going to divide both sides by negative 1,536. They reduce on the right-hand side, and I'm left with approximately 0.1504 equals the cosine of big C. And to get C all by itself, I need to undo cosine with the cosine inverse. And I'm left with approximately 81.35 degrees for angle C. In this last problem, we're going to solve the triangle, which means we're going to find all the possible missing measurements for side C and angle A and angle B. Since I see SAS, I'm going to start with the law of cosine. C squared equals A squared plus B squared minus 2 times A times B times the cosine of big C. C is the only angle in my formula, and it just so happens that it's what my angle is labeled as in my diagram. So I'll relabel across from big A is little a, across from big B is little b. And at this point I'm going to plug it all into my formula. So I have c squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 37 degrees. Since everything on the right-hand side of the equation is plugged in, I'm just going to type it into my calculator, and I get approximately 44.44. Then to get c all by itself, I'm going to take the square root of both sides, and when I do that, I get approximately 6.67 for my side length c. Alright, from here I still need to figure out angle A and angle B. I could choose to use the law of cosines again, but I prefer to use the law of sines at this point. So let's say I want to solve for A theta first, and that's across from that 8 side. 37 degrees is across from 6.67. So now I'm going to set up my law of sines. Sine of my angle over the side is equal to the sine of the angle over the opposite side. At this point, I'm going to cross multiply, so I have 6.67 times the sine of theta is equal to 8 times the sine of 37 degrees. At this point, I'm going to divide both sides by 6.67, and they reduce. And last but not least, I'm going to take the sine inverse of both sides to get theta all by itself. I'm going to type all of this in my calculator all at once, which leaves me with 46.2 degrees for theta. Last but not least, to figure out angle B, I could choose to use law of cosines, I could use law of sines again, or we could remember that all the angles in a triangle have to add up to 180 degrees. So if I take 180 and subtract 46.2 and 37 degrees, I'm left with 96.8 degrees for angle B. And now my triangle is solved.